The IPC 2223E standard, developed by the Flexible Circuits Design Subcommittee, provides comprehensive guidelines for designing flexible and rigid flexible printed boards. It supersedes previous versions, ensuring up-to-date practices for engineers and designers in the electronics manufacturing industry. The scope of IPC 2223E encompasses design requirements for flexible and rigid flexible printed boards. It includes insulating films and metallic materials, supporting single, double, multi-layer, or combined flex and rigid configurations. This standard ensures comprehensive guidelines for diverse board types, enhancing design precision and reliability in electronic manufacturing. The purpose of this section is to establish design details for flexible and rigid flexible printed boards, aligning with IPC 22221 and IPC 22222 standards. Product classification follows IPC 22221 guidelines, covering single-sided, double-sided, and multi-layer board types. This ensures consistency and reliability in design and manufacturing processes. Type 1 single-sided flexible printed boards feature one conductive layer, constructed with either adhesive or adhesiveless substrates. Figures 1.1 and 1.2 illustrate these configurations, highlighting components like access holes, coverlay, and copper pads. This design is crucial for applications requiring flexibility and minimal layers, setting the stage for material selection in flexible boards. The materials section delves into dielectric and conductive material selection for flexible boards, covering prepreg, adhesives, and surface finishes. It discusses electrolytic copper plating and other metallic coatings, essential for ensuring optimal performance and reliability in flexible circuit applications. Fabrication requirements encompass bare board and roll-to-roll methods, crucial for flexible and rigid flexible printed boards. Product configuration addresses circuit profiles and rigid area considerations, ensuring optimal design. Detailed guidelines for flexible areas and preforming bends are essential for maintaining integrity and functionality in dynamic applications. Electrical properties are crucial for flexible and rigid flexible printed boards. Key factors include impedance modeling software and material thickness. Conductor pitch and differential impedance are essential for effective design. These elements ensure precise control over impedance and capacitance, vital for optimal board performance. Thermal management is vital for board integrity, focusing on component placement and surface mount requirements. Key constraints include mounting on flexible sections, ensuring optimal heat dissipation and mechanical stability. Proper assembly techniques are essential to prevent thermal stress and maintain performance, setting the stage for effective interconnections and hole management in subsequent design considerations. Holes and interconnections are critical for board design, focusing on land and annular ring requirements. Both plated and non-plated component holes are essential, with specific guidelines for coverlay access openings and spacing. These elements ensure reliable connections and structural integrity in flexible and rigid flexible printed boards. Conductors focus on routing and edge spacing, crucial for performance. Large conductive areas and land characteristics are vital for stability. Documentation and quality assurance ensure designs meet Institute for Printed Circuit standards, maintaining reliability and compliance. These elements are essential for effective design and manufacturing of flexible and rigid flexible printed boards. In conclusion, the IPC 2223E standard provides comprehensive guidelines for designing flexible and rigid flexible printed boards. We encourage active participation in future revisions to enhance these standards. For further details or to get involved, please contact IPC. Thank you for your attention and commitment to advancing our industry standards.